But I think I have to start with something very boring. But why exactly is your first name Keno? Because as far as I understand, you're German, and I've lived in Germany for 17 years or so. I think you're the first person I've ever actually heard the name.
Yeah, so it's a bit of an unusual name. That's true. So
and is it Keno or?
Yeah, it's Keno. Yeah, exactly.
Okay.
And I'm originally from the northwest of Germany, so Ostfriesland, and It is a relatively common name there. So it's not super common there either, but it's like a traditional name from that area.
Oh, I didn't realize it was actually a German name. I thought it was something like, I don't know, parents like Japan or something like that. I don't know.
Yeah. A lot of people say that it sounds like a Japanese name.
Yeah, that was my assumption. Maybe because it sounds like kendo or something like that. Okay, so there's literally no story. It's just from the area. Huh. That's weird because my family is also, not like northwestern Germany, but my grandparents' generation are from Emsland.
Oh, okay. Yeah, that's pretty close.
Okay. I have no real relation to that area.
Yeah.
I've been there, I think, twice or something. But yeah, it still surprises me, though, that I've never heard the name. Anyway, I guess that's not...
No, but it is a fairly sort of confined area where you would encounter that name. So even in the Emsland, it's probably not something people would generally hear very much.
Okay. Yeah, also the names that I'm familiar from that area are, 2 generations in the past. So everyone's called Hermann, basically.
Okay.
Anyway, so yeah, as I said, I'd like to talk about these 2 articles of yours I've read. Where does value come from? And optimal utility and probability functions, etc. And I thought maybe we can do that by talking about kind of how you got into that and how those projects started.
Yeah.
And maybe the first question is just, so in 2012, you have a paper called The Social Side of Gaming, How Playing Online Computer Games Creates Online and Offline Social Support. How exactly do you go from there to what you're doing right now and what you've been doing in your PhD?
Yeah, that's an excellent question. So when I was doing my undergrad in Hamburg, I worked as a research assistant in media psychology. So at the time I was interested in media in general. And I also, before I started studying psychology, I thought maybe I want to do a politics degree. So this seemed like a good compromise to still be in touch with that. And while I really enjoyed working in media psychology, and where I also worked on this paper that we wrote together, I sort of realized that I'm more interested in sort of neuroscience. So the brain, broadly speaking, was what interested me more in my studies than media psychology per se. And then when I did my master's, I did a project with Chris Summerfield, which developed into a paper later on. So that's sort of when I got back into the decision-making field. And I think that was my first sort of first-hand experience with that kind of area. But funnily enough, so this optimal utility functions paper builds a lot on what's called prospect theory, so like an economic theory from the 1970s that sort of incorporated a bit of psychology into mainstream economics. And that was a paper I wrote an essay on in my very first semester in Hamburg. And I was really interested in that. So it's kind of funny that it's like a bit full circle.
So it seems like you changed direction completely, but you wandered about a bit and came back to what you started with. Okay, yeah. But what was your... I was also just generally curious on, I think it's the St. John's College, or
yes.
College? Yeah. It says, my background is in psychology and cognitive science, which sounds very mysterious. Was your master's then in Oxford or was it somewhere else?
No, I did my master's in Osnabrück. So... sorry to interrupt, but I thought, should I do the risky gamble or not of suggesting that you either did your master's in cognitive science in Magdeburg or Osnabrück? I think those are the 2 places in Germany, right? Yep. Where a lot of people seem to do very well afterwards after doing that master's. And I thought, nah, it's probably not going to be true. No, it is. It
Here
is.
we are.
Yeah. So like after my undergrad, I took a year off and sort of thought about what I wanted to do. And I really wanted to go into research, and the psychology degrees, as you probably know, are fairly heavily focused on clinical psychology or organizational psychology. So I really knew I didn't want to continue with that. And then I just looked for good research-focused degrees, and cognitive science was one of them I'd actually looked at for my undergrad as well. And then I really like that it's a very, very flexible degree. So you can more or less focus on whatever you like as long as you tick a few boxes. And that's where I learned programming, and it fit into the program, and it was really good to do it there.
Can you talk just briefly about the program? Just because, yeah, as I said, like I feel like half the people who studied for their masters in Germany, they did one of those two programs. Maybe that's wrong, but that's at least the impression I'm getting. So it seems to be a very good program that people seem to like quite a lot. And I'm also curious then, Chris Sommerfeld isn't in Osnabrück, right? And I don't think he ever has been. Yeah. So how did that exactly come about then? Yeah,
so about the program. So I think it's an excellent program for if you want to go into research. So if you want to do something else afterwards, like actually work as a psychologist, for example, then it wouldn't be a good degree, but I think it's a good preparation for research because it's very flexible, and it also, at least in the undergrad, really focuses on philosophy of science, philosophy of mind. You have to do lots of programming and mathematics courses, and you don't have to do those in the master's, but you can, and they're sort of easily available to you. And I did some of those. So it's really good preparation if you sort of want to pursue a career in something that's researchy, even if that's working for a company afterwards. And yeah, to answer your second question, when I started in Osnabrück, some people who were doing their PhD in Oxford but had done their undergrad in Osnabrück, they contacted the Fachschaft, so like the student body of the course, and asked whether people would like to do a visit to Oxford. And I was like,
everyone said no.
Yeah, exactly.
Why would we want to do that?
So I was one of the lucky ones who actually got to visit. And I, at the time, was thinking about doing my master's thesis like abroad anyway. So I was already thinking about somewhere in the UK. And then I just contacted a few people, and Chris was one of them. And he was fairly open to me doing that. So a year afterwards, I came over to do that. And haven't left Oxford since, essentially.
Chris hasn't left you. It's funny to me how like a lot of these things are just, similar. Like all of my master's programs, like I had like something where I did 2 research projects, and all of them were just I contacted people I thought whose work was interesting, and then for some reason they responded, which is always, I don't know. I guess like when you're at that stage, I didn't necessarily assume they would. But
yeah, it's easier than you think, really, when you try it. And it also seems a lot more intimidating to contact these people when you're just doing your master's. Exactly. You don't know how that kind of interaction works. So I definitely, it took me many hours probably to write these emails to people.
Which is, also why they were successful, right?
Maybe.
If you just write like, "Yo, Chris, can I come hang out with you?" Then?
Well, actually, I actually didn't address it to Chris because at the time his email address for the lab was neuronoodle, and it's still an inbox that some people use for the lab. So I just addressed it as "Dear Neuronoodle" rather than Chris.
That's how long did you think about whether you're going to write that?
Probably for very long.
Yeah. So can I really write this? Well, it seems to work. Although we should probably say, if there are people applying for master's projects, only do that if that is the email address of the lab. Don't just randomly contact people with Dear Neuronoodle.
I probably made sure that it definitely was, yeah.
Yeah. Okay, cool. So was it then, I'm assuming, I don't know how, when you contacted the Neuronoodle, was it a fairly generic kind of like, hey, I think your stuff is cool. Can I do my master's project with you? Or did you come kind of with ideas already to do something specific?
Honestly, I don't really remember, but I probably didn't come with a very specific idea. Maybe I wrote about some things that I was interested in, that I was interested in decision making, and that's what he worked on, or still does. But I probably didn't have a specific project idea in mind. But I do remember that he gave me a lot of reading afterwards, so for suggestions, and asked me to have a look at that, and then we could figure out a project once I moved to Oxford.
Okay. So how do you go from master's projects to PhD? The standard route of applying for stuff, or did he have funding, or how does that work?
So it's a bit different from Germany, maybe the way it works in Oxford, because it's an actual program. So in Oxford, you can apply for open positions, right? And then it's like a job. You're basically employed on the project of your supervisor. That's not really something you can do in Oxford. So you do have to go the official route and apply through the university program. So I did that about a year after I did my project with Chris, I think, after I started maybe, because it's one round a year. And then I had an interview, and then there's usually a sort of uncertain long period of time when you get your offer, but you don't have funding yet. So Chris said he might be able to fund me anyway, but there's several rounds of internal funding that you might be able to get in the end. So after maybe 3 months.
Oh, sorry. So you got accepted into the program, and then the question was, they said okay, in principle you can come. So the program isn't directly, acceptance into the program isn't directly linked to actual funding.
No, unfortunately not. So I think they accept about 20 people every year, and maybe 10 would get full funding from various sources. And I don't know how the other 10 really do it, because you also have to pay tuition fees in Oxford, which is, I think, about £6,000, which is just a home fee. So if you have citizenship that isn't European, then it's at least twice as much, maybe even more. Yeah, so it's quite expensive for a program where you think, I don't actually take any teaching. I'm just working here. So it seems like quite a lot of money if you don't get funding. And well, it definitely is a lot of money. Yeah, but I was lucky that after a few rounds, I did get full funding for 3 years. And that's another thing, actually, that the people who do get full funding, like me, they would have 3 years funding. But most people need about 4 years. And I also needed 4 years. So for the last 1 year, you kind of have to either fund it yourself or get funding from your supervisor. So for me, it was a bit of a mix in the end. And I was also able to extend my funding a little bit because I did a visit to another lab during my PhD, and then they sort of extend it afterwards. But that definitely is a bit of a problem.
Yeah, it's really weird. In a way, it's especially in the UK. I guess it's in Germany. It's becoming more common also. But these 3-year PhD programs. I mean, you can finish in 3 years, but it seems to me from most people I've heard also who've done very well in their PhD, right? Like, for example, you had some very good publications out of it. It's not as if you were just sitting around all day, didn't get anything done. Most people say you need 4 years basically. And yeah. So I wonder sometimes why they do these 3-year things when basically everyone kind of needs more anyway. I guess it's so they can offer more positions, but
yeah, I'm not really sure. And it also really depends on what kind of PhD you're doing. So in my program, it's for the entire psychology department. So if you're doing something like me, where you can do your experiments, and some people might just do behavioural experiments that aren't all that time intensive to run, or don't take as long to analyze. So you can definitely, if you really, really want to, you can probably do that in 3 years. But then others are working with clinical populations. So that will take at least a year or more just to set up your study, and then you have to collect the data and find patients who want to enroll in your study. And that's almost impossible to do in maybe even 4 years.
Yeah.
Some people would even need more time, and some people do get an extension because of those circumstances.
Yeah. Anyway, so before we started recording, you said that the optimal utility paper kind of came first in a sense, or that those you were early on more interested in those kind of topics?
Yeah. So in a way you can kind of, sort of biographically, it fits very well with the very first study that I did with Chris, which was another gambling study where we were looking at how people change their risk preferences based on how much money they've accumulated over repeated gambles, and where and how that might be represented in the prefrontal cortex in the brain. And so I spent a lot of time working on utility functions and sort of economic decision making during that time. Then there was a bit of a break that's led to eventually to that where does value come from paper. And then this optimal utility function sort of circled back a little bit, but started off as a project that someone else was leading, actually, and I only joined it sort of halfway through. So this was like a very, very collaborative project that I was sort of later sort of tagged on to because I had already worked on something similar.
I see. So, I mean, I guess maybe if you weren't, I mean, you might not have been there right from the beginning, but what was kind of the goal of this project? Or, yeah, do you know how it started? Or, I mean, I guess I'm kind of asking because I'm off right now, but, you know, I'm also in my PhD and you do these research projects, and sometimes you have things that are very kind of clear cut, and you have this idea, you do it, end. And sometimes you have these things that kind of shift and change as you do them, and you know, you don't even know how many papers it's going to be, or you know, all these kind of things. So I'm just curious, kind of, what it was like for this one.
Yeah, so for this one, it sort of started off as part of the research agenda by Bernhard Spitzer, who's one of the senior authors on the paper, who was doing a postdoc with Chris at the time. And he's been working a lot on how noisy encoding of decision variables. So, for example, we might see a number of dots on the screen, but there's a bit of uncertainty about how many we might see at any given point in time, just because of some variability in our internal processing. So he's worked a lot on that side of things, and he was really interested in how you might apply this to economic decision making as well. And I guess the overarching goal of this project was to sort of take these two phenomena that people don't encode value linearly, and it's a very consistent finding that, for example, the difference between £1 and £2 seems a lot larger than between 101 and 102 pounds. And that's a very consistent finding. And there are various hypotheses about why people might show such a pattern. And then there's a slightly disjoint set of findings about how people represent probabilities. And there the consistent finding is that you sort of over-represent unlikely events. So you think they're much more likely. And that's maybe why people play lotteries, for example. And you, at the same time, underrepresent really almost certain events. And so when this project started, it just seemed like maybe there's like a really simple set of assumptions we could make that would lead to sort of, in a theoretical world, would motivate why a decision-making system might have these distortions in the value and probability decision-making.
Yeah, and I mean, those, you said there's like two different things, but they kind of come from the same people or research area, right? It's kind of judgment and decision making. It's not like it's completely different fields, right?
No. So sorry, I meant that usually when people have tried to motivate why people have this, for example, value distortion or probability distortion, it's usually done separately rather than in an integrated way.
Yeah.
So in like a theoretical sort of way, they're often a bit disparate, but they are two parts of the same problem, if you will.
Mm-hmm. Okay, so the kind of origin story of the paper is then actually quite similar also to the way it's written.
Yeah, I think so.
This was kind of one thing I was curious about, like, you know, you write about these two assumptions that you have in here, that people, what is it, value uncertainty, and the other is, God, what's the other one now?
There's noise in this.
The noisiness, yeah, exactly. So you have those two, and I was curious, like, did this kind of come from someone just like messing around and trying out different things? And
so the noise was definitely at the beginning. That's something that Bernie is really interested in various domains. So that was really the motivating starting point, and then and then that's also kind of following how the paper is written, is that when you just assume that people are a bit noisy in their decision-making, you do get the value encoding for free. So you find that an optimal decision-maker that is a bit noisy should encode values more or less in the same way that we find people to encode them. But you don't see that there is a similar probability weighting function. So the optimal decision maker would essentially not differentiate between value and probability and encode them the same way. And so then we needed an additional assumption to motivate that. And then as is assumed in a lot of psychological theories, of course, is that people value certainty, and they just want to know what the outcome is, whether or not they're getting it, or whether they're sort of invested in the outcome. And then you just plug that in, and you then get this probability weighting function for free as well. So it's just these really small assumptions, in a sense.
So this is something that just occurred to me whilst you said it, is that, okay, people value certainty, certain outcomes over uncertain ones. And there's obviously, it seems to me there's a much more direct link here between that and the probability distortions, let's say, compared to people have noisy decision-making and value, right? That's less tenuous. The other one seems fairly obvious, but then it just occurred to me, it's kind of counterintuitive that if people value uncertainty, they overestimate uncertain events and underestimate very likely but not certain events. Yeah,
so you really do need the combination, I think, of the noise and the valuation of certainty to get this pattern. I think we might have tried this without the noise at some point and it didn't come out. So then either a form that looks like the value encoding or a linear encoding is optimal, I think. But I may be misremembering something here. But so one theoretical background to this was that in 2016, I think, there was a paper about how the probability encoding might come from noisy encoding of probabilities. So to backtrack a little bit, there's this kind of phenomenon in auctions when, so let's say I'm auctioning off a $100 bill or something, or sorry, like a jar of $100 bills, and you don't know exactly how many are in there. Then the final product that you might auction from me, that you might bid on, is worth exactly the same to anyone who placed bids on it. But the person who is most optimistic will win and get the money. But they were also likely a bit overestimating compared to everyone else. And that's what's known as the winner's curse. And you can make a similar argument for probabilities, so that if your system is a little bit noisy, then the fact that you chose something might just be driven a bit by your internal noise, and you have to correct for that. And then they've shown theoretically that one way to correct for this winner's curse, in a sense, is by having exactly this type of probability distortion.
And the two of them together then lead you to...
Yeah, so something that their theory wouldn't be able to do is sort of differentiate between... So in our experiments that we ran, we had two different groups, and they only differed in the type of feedback that they received. So one group would just get the expected value of an outcome. So, for example, just multiplying the value and probability, and they would receive that. Whereas the other group would actually play out those gambles. And then so, because the labels were essentially the same and the experiment setup was identical, then if you encode probability in one way, then you should do it for both groups. But we've sort of shown that it really depends on how things are presented and whether things are actually risky or not. And their theory wouldn't have been able to sort of make this distinction between the different experimental manipulations. But I just want to sort of highlight that I think the contribution of our paper is that we have just two very simple assumptions that bring together these two findings that can be explained in other ways as well. It's not like we haven't come up with a completely new explanation, but I think it's a nice joint explanation, perhaps.
It's not like you're the first people who ever tried.
Yeah, exactly. No, not by a long shot.
It's only been like 30 years of people doing that. But no, I mean, I do like the idea. I mean, I guess that's kind of the maybe often implicit goal of science, right? Is to explain as many things as you can with the simplest assumptions and the simplest model, right? That's kind of, well, I say implicit, but often it's also very explicit.
And I think,
so from that perspective, I think it's really nice that you also have assumptions that are I think most people would agree with. I don't think there's anything controversial. It's not like the kind of thing you have, like, we have this model and it rests on a really weird assumption. It rests on assumptions that they definitely make sense, I think, from a common sense perspective. But they also just make, especially the noise part, just also makes from every scientific evidence thing. I think the certainty, I don't know too much. I mean, it's a common assumption everywhere, but I don't actually know how much that's been. I know there has been tested, right, with different gambles and that kind of thing.
Yeah, so there's also this literature on curiosity, where so if you can even study this with monkeys, for example, where they might choose to play a certain type of gamble, and then they can additionally sort of pay or wait to see the outcome of that gamble, and they really, really prefer that, even though it's non-consequential to them actually receiving it. And you can show the same thing in humans. So there's this kind of element of kind of wanting to know what you're going to get. And
do you know what paper that is? The one with the monkeys?
By chance? No, not off the top of my head. It might. I'm pretty sure we've cited it.
Okay, I'll have a look. I mean, I'm just asking because I always put all the papers we talk about in the description of the episode, so people can, don't have to search through forests, right, but can just see what the relevant papers are. Okay, then I'll try and figure it out.
But I can certainly find it as well and send it to you.
Mm-hmm. Thanks. Actually, was it something you wanted to say before something? Okay,
I'm not sure.
If not, I'll just continue. So there's kind of one big picture question I have, which is something that occurred to me whilst reading your paper and related papers recently, is that it seems to me there's in science you always have this back and forth, right? Someone says something, then people say, well, it's actually not that right, and then you go back and forth on these things. And it seems to me when it comes to kind of optimality, and how on rationality in these things, it seems to me that we've kind of reached the third level of this conversation now, where the first level is kind of people say, like, this is kind of expected utility theory, this is how rational people behave, that kind of stuff. And then the kind of, let's say, behavioral economics view then came along and said, like, well, actually, people don't do this. Look, here's all these experiments that show that people don't do this. And it seems to me we've kind of now reached the third stage where people say, okay, people aren't like rational according to expected utility theory, let's say. And they do have these biases, but the biases are actually rational once you account for the fact that it's a biological organism do it and it has certain limitations. And to me, at least, it seems like that's kind of where we're at right now, where your paper included. There's this kind of slight, let's say, behavioral economics maybe overcorrected, and now kind of correcting back and saying, like, well, there is some rational. It's not completely wrong. Is that a fair assessment?
Yeah, I think there's certainly a good element of it, and that's kind of what I like about this research area, is that recently there've been a lot of attempts to bring it back a bit to biology. And so I guess when I started maybe my master's or something, like, optimality, like it always sounds so final in a way. It's like, some things are optimal and others aren't. But really, just about anything can be optimal as long as you just define your criterion correctly, right? So I think and it's just that people just assume that, the criterion that people maximize is money or some other good that you might look at. And that's clearly not how it works in biology. And we sort of first have to really think about what is it that biological organisms are optimizing for. And then the questions become a bit more fraught and intricate.
So is it fair to say then that it's just the kind of expected utility theory, the people who did that assumed a specific context and thought it was the context, the context of optimizing how much money you make. Whereas if you, as you said, it can be, depending on context, lots of things can be optimal. So it's more a matter of, they just chose one context rather than any of the others that exist, or
Yeah.
I don't know. I mean, I'm just
Well, I also think, I mean, it's a very flexible theory. Like there's a huge range of actual decision rules and functions that it can accommodate. So it's not necessarily that it's sort of clear cut what the final product should look like. But I think what it's really highlighting, and sort of what I take from it, is that what people really should be is consistent. So if you can optimize whatever and you can have whatever preferences, but I should be able to predict that if you do something in context A, you should do it again in context A and maybe switch in a different context. But there should really be this element of consistency. And I think for a lot of economic decisions, whether I want to invest my money somewhere or which job I take based on certain criteria, there probably is a fair amount of consistency most of the time. So I do think it probably comes close to that. But there still is sort of like that lurking background question of, what's the sort of thing that you might be optimizing that this thing would then give you consistent preferences for?
Not sure exactly in the last sentence.
Yes, it was
elaborate on that a bit.
I mean, biological systems optimize various variables, right? So you might be like, something that I'm interested in is sort of how do you get from that to having consistent preferences in this super artificial paper money or digital number system, where you suddenly have people make broadly good decisions, and they might be slightly off sometimes and slightly biased, but broadly they're as you assume they might be. But how did the system sort of evolve, and what is it optimizing for? That's actually something that's possible, that we could invent it a few thousand years ago to have such a system.
Okay, so where do you? One kind of question I had also when I gave like my very brief overview of these kind of three stages. Where do you think this is going? I mean, so now we have this more like making it realistic, you might say, or for a biological organism that humans are, just making it realistic. Is that kind of the end stage of figuring out exactly how that would work, or is there kind of a next stage for the kind of evolution of this argument? You know, like once you figure that out, what do you think where does that lead us?
So I guess something that you really want to focus on probably is you want to be able to measure people's behavior in certain situations, and you want to be able to transfer that to new situations, so you're good at predicting things that you haven't observed yet. And I think we can probably do that in like monetary decisions, but I don't think we're very good at doing that for more mundane and everyday decisions. And I think where this whole literature might be going is to focus a bit more on transfer and generalization. And that's certainly where at least in my own sort of view of this, which is of course biased in some ways, is where the decision-making literature seems to be going as well. It's like a big focus on, you observe something in context A and you want to be able to predict something in context B, sort of the stability of it.
But in this case, where the contexts are quite different, rather than this kind of gamble versus this other monetary decision. But you mean like more kind of saying, okay, how do these kind of gamble findings, or how do our predictions that work here, do they also work for, I don't know, eating? Or do they work for, I don't know, what job to do, whatever, right? Like just that kind of thing, you mean? It's kind of,
yeah, for example.
Yeah.
Or like maybe so people might have measured people's utility functions and then used to predict whether they want to play some risky gambles or whether they want to take out insurance and that kind of stuff. And that might work quite well. But maybe there are even different types of measurements that we want to take maybe in completely different tasks that better describe how people will behave in other situations. Mm-hmm. So I think it's often a question of like well, what do you want to use it for? And like if you just work, say, in the financial industries, then you probably don't need to worry about this too much, because your models are sort of approximately fine. But if you're interested in how all of this is implemented in the brain, then I think it matters quite a lot.
Right. Yeah, this kind of relates to something I just wanted to ask, which is kind of why are we searching for optimality or deviations of optimality? What exactly is the point here?
So I sort of alluded to this earlier, is that I think you should be careful with calling something optimal or appealing to optimality. But what I think it's very good for is from a sort of modeling and understanding perspective. So if you have a model that makes certain assumptions about what is being, well, now I want to say optimized, but something that's that it's trying to achieve in a way, which is, I guess, the same way of saying it.
I was about to say that.
Then you can sort of see how far that theory can push you, and use it to make predictions about where you should pose your next experiment, or maybe look for brain signals anyway. And that's, I think, where appealing to some sort of optimality is good for. And I think we implicitly we do that for most aspects of science, but we may not. Like as soon as you're using some kind of model, there is some implicit appeal to optimality sort of baked into it.
I mean, it seems to me in physics, let's say, if you have a theory of gravity that doesn't optimality, it seems to me like there might not be you don't go, is the gravitational system optimal with response? Right. You just go like, how accurate am I describing this, right? So is the difference here that the thing that you're modeling is trying to do something rather than just existing in that sense? Is that the difference here, or?
Yeah, I think part of the difference is that you have a system that makes decisions, and it makes decisions to some end, and usually just having descriptive theories are, they're nice, but they usually don't make very strong predictions about situations that are outside of the things that you've looked at. And for that, I think it's from a sort of understanding perspective, I think it's really, I tend to personally think of it as like a tool for understanding, more so than necessarily saying that this is exactly what people like, that there is some wheel in their head that counts. Like, am I really certain or uncertain? I think it's like a epistemic sort of tool.
Yeah, and I mean, that's also kind of what you wrote a few times. I think your abstract on the end of the significance paragraph, this kind of idea that, actually having some sort of causal explanation rather than a mere description. And as I agree, like descriptions are perfectly fine. That's also how you start, right? Yeah. You don't start by causally describing something before you know what you're looking at. But yeah, I guess that is kind of the nice to maybe slightly close off this part a bit. I think what the nice thing about this paper is that, you have these two fairly basic assumptions that aren't even particularly specific to the context necessarily that you're looking at, and that through that you can achieve this kind of, not exactly causal understanding, but it's a potential explanation of these things that people have been talking about for decades now.
Yeah.
Yeah, I have to ask one question though, which is something I was curious about, and I think it's one of the last sentences you have. It's actually the very last. Maybe I'll just read this. Nor does our theory consider the most distinctive contribution of prospect theory the intuition that computation of value is reference dependent, with all utilities evaluated relative to a status quo given by the current context. The normative properties of such reference dependence, for example, in the context of efficient coding and efficient computation, have been discussed elsewhere. So I haven't read this paper by Sommerfeld and Tsetsos, but just briefly, so I'm kind of partially interested in these kind of losses and gains things. Mm-hmm. Can your paper say anything, or your kind of model say anything about that, or is it really just this only works in the gain context? Don't ask me about losses.
Yeah, I mean, I haven't looked into the the loss framing that much, so I'm not sure what the model would predict there. But I don't see any reason why it shouldn't be able to at least. I mean, it's essentially just the same function. It's just flipped. The only thing that it doesn't, that I'd be surprised if it really fit, was whether people are more loss averse, like have a stronger coding for losses than they do for gains. So I don't think that the model would necessarily do that.
So you're assuming symmetric?
Yeah, I mean, for the purposes of the paper, we were sort of assuming that there are no losses at all. So I guess we're sort of avoiding that question a little bit. But I mean, there's ongoing debate about how much of a thing loss aversion really is.
Yeah, definitely.
So it may not be as strong as we might have assumed a few decades ago anyway. And the sort of, I think the more general point is that, so just by saying that there are gains and losses, you're already assuming something like prospect theory, because losses are actually also not defined in an expected utility function in its sort of earliest incarnation. So that is an additional assumption that we've sort of just implicitly made, and your reference point might switch and like turn losses into gains and vice versa in various interesting ways, but we're just not looking at it. We're just assuming that there is a reference point that you're using.
Yeah. I mean, so one reason I was asking about this is because this is something this is a kind of, I guess, like meta science, how to do science, and also like what a paper exactly is. Because, so this is something I did basically the first thing I did with my PhD, and it's not out yet. And we still want to do like at least one experiment, but it seems right now that we kind of did a different decision-making context, a more social context, and we find not exactly the traditional loss aversion definition in terms of different slopes for positive and negative values. Mm-hmm. But people definitely try and avoid losses in this context. So I had this kind of very simple way of testing this where, okay, something could be a gain or a loss. And I had this like very neat way of doing it. And I was very happy with that. But it avoided zero, because zero in this context was difficult to interpret. And mm-hmm. In the way that I set it up, it made it a bit awkward. And I thought, well, I'll just do gains and losses, right? Like, don't care about zero right now. I'll figure that out later. But then at some point, as I was, analyzing my data and thinking about it, I thought, like, are you stupid? You can't do a theory about like how people behave in this and just avoid the concept of zero. Like it's a real thing. You can't just pretend it doesn't exist. But it seems to me that's kind of exactly what you said you did, right? And my question there is kind of like, I guess the general question is kind of like that I'm struggling with is like, when is a paper finished and how much does a paper have to achieve?
Right.
Because it seems to me that saying like, if you do something that is about like gambles and things, working out to different degrees in terms of how much money you get, it seems kind of so incomplete to not include nothing happens or you lose money. So yeah, I'm just curious, like how you think about that kind of problem.
Right. So I guess so we're implicitly assuming, I guess, that the 0 point for people is just however they come into the experiment. And then, like nothing happens would be one of the possible outcomes of the gamble. So in one of the groups, at least, we did have that nothing happens. But yeah, the more general point of like, when is a paper finished? I mean, I think that's very difficult. I mean,
that's why I'm asking you and not vice versa.
I think like when you have a paper, I think it should make an interesting point about some phenomenon, and ideally also include maybe some modeling where you might sort of again have a more theoretical understanding of what you're looking at. And if that's then also surprising, then maybe it gets into higher journals, because that's sort of what they reward, I guess, whether something's surprising or not. But I personally don't think that a paper really, like, as long as you're not writing a theory paper and it's still about sort of empirical data, I don't think it needs to look at all the different aspects that you might also look at, I guess, from one theory. So I think we've sort of just taken the sort of basics of the problem and just looked at those, and then you can do a follow-up study. We might do it. We don't have very specific plans at the moment, but we probably mentioned those in the discussion, that there are like various ways in which you could extend this. And I think having this solid base that you can sort of work off is, I think, then worth publishing. And then either you or other people can work with that. Because otherwise you'd probably just end up having huge projects that either take years to completion or maybe never get finished, because you also have to do other things, and probably need, like, sadly enough, you also need some papers like fairly regularly. So there's definitely an incentive to maybe be a bit more incomplete.
Yeah, that's another problem, where I basically have like these few experiments that are kind of smaller experiments we did, and they seem to kind of work out. And then I realized, like, well, I can actually generalize this to a much broader way of testing it. So not like so specific to this one task, but it's a much more general way. But then I realized, like, well, if I do the first one basically doesn't matter anymore, because the second one kind of includes the first one in some sense. So, like, do I even need to publish the first thing? Like, because, if I publish that and it replicates in the other one, then it's like, okay, the second one by itself would have said that. If the first one doesn't replicate, then, you've created a stir around something that doesn't work. For however long it took you to finish the second one. So yeah, but then I also, I also know that, if you don't publish stuff, you're not going to get a job afterwards. So it's, I find it a really difficult problem.
But I think there's also it's also a communication aspect, I think, in that, like, you might go to conferences and talk to people, but really the major way you communicate with other scientists is through your papers. So if you have something that you believe in, and you've sort of made sure that, you've ruled out other alternative explanations and stuff, then it may be worth publishing just for that aspect of it, that other people then know about it, and they can take it and do whatever they want with it. Maybe it doesn't replicate in your own work, and then you can say that later on. And I guess that's just what happens. Like, not everything will replicate.
Yeah, and I guess, it's not like we're, doing something and then, p-hacking or pulling stuff out that isn't in there. There was a initial thing that we wanted to do, and it seems to work out. So it's not like, we're presenting exploration as hypothesis-driven research, but it just feels so. I don't know. It feels a bit like I'm not doing a proper job in that sense. Present it once you're finished, right? Rather than, but I guess.
Yeah, it's hard to say from as a sort of general point, I think. But if you think that what you have at the moment makes a valid point, then you might think about publishing it now. Or if you think that maybe in a year's time you have something more general that makes a valid point that's bigger than this.
It would make the same point, but yeah.
But also from a practical perspective. So depending on what the point is that you're making, if you have something that already went through peer review that you can point to, that might reinforce people might be more inclined to take it seriously if there's already published evidence on it. Depending on how novel it is, but it might be a problem you encounter.
Yeah, I don't know. Novelty, and I have to admit, I think especially when I was in my bachelor's and master's, it seemed always like, people have these findings that come out of nowhere. And then once you start doing the field, you realize that already existed. Why is this in psychological science or whatever? Why is this such a big deal? So I think I still have a lot to learn about academia as an enterprise rather than science per se.
Yeah. And the novelty is you have to ask yourself, novelty to whom, right? It's something may be very well established, some methods, for example, in neuroscience, there are a lot of methods that now come from physics, or even pure mathematics. And if you showed this to a mathematician, they'd be like, well, duh, I already know this, and it's been proven for many years.
Yeah.
But neuroscience is still, like, it hasn't been applied yet, and people still need to sort of know about it. So I think it's really easy to, like, when you're so deep in a topic, and you read widely, then it might seem that something, that it is, that it's maybe been around for a while, but that may not be the case of a lot of other people. So it might still be worth it.
Yeah.
Like, as long as you shouldn't then sell it as being something very novel, but that might explain why some things sort of get rehashed a few years later.
Yeah, I mean, that's always the kind of classic thing, right? You think you have this new thing, and then there's 10 papers from the 60s or something that have been cited like 10 times, and they kind of already did what you wanted to do. Although I like finding those papers. It always feels like you found something hidden that no one knows about.
Yeah, exactly. Yeah.
Anyway, I think, shall we end my therapy session and start talking about your other papers?
That's true.
So, very dramatically, I'll turn the papers so I have it in front of me. So the other paper is, where does value come from? And can you maybe explain what exactly the problem is with reinforcement learning that you're highlighting in this? And if you can do so, maybe also explain what reinforcement learning is, but maybe we have to do those in two separate steps.
Sure. So I guess the problem that we're interested in here is where an agent, so for example, a person or an animal, interacts with an environment, and so they do something, and then they see how the environment reacts to it. So for example, you might go into your kitchen and eat something, and then what in reinforcement learning is classically assumed is that you would then or have an observation, which is sort of like the world has changed after you've acted. So what does it look like now? And you also get a signal that you might call reward, where it's sort of telling you how good or bad it was that you've just done. And both of these things, at least classically, come from the environment. So it's something external to you. And then you take this reward signal and you want to get most reward over a long period of time. So you're sort of like a rational agent that wants to maximize its reward or happiness or whatever else you might want to call it. But then the problem that we're highlighting is that, at least in psychology and neuroscience, we often assume that we know exactly what that reward is. So it's fairly straightforward. If like people are gambling for money, like in our recent study, then it's probably fair to assume that this is what they're interested in maximizing, the amount of money they gain over the course of the experiment. But things are a lot less clear if you include things like social decision-making, or even just things like when you decide to eat and when you decide to drink something, or when you decide to exercise and so on. So the problem that we're interested in is like what an agent or a biological system has to do is it sort of takes the observation from the environment, but it then sort of splits that into, this is how the world has changed, but also something that I can use as a learning signal to make better choices in the future.
So I think if you've already alluded to this, but I don't think it's maybe not said exactly, what you call the reward paradox between this kind of like the reward is out there, but then it also kind of has to be generated internally. Can you explain that a bit? Yeah.
So like I said, in most scenarios when reward is generated and when the environment gives you reward is either given by the experimenter, so exactly when I pay out money, or when you're teaching an artificial system, it receives these numerical rewards once in a while when it does something good. Like for example, a self-driving car, when it doesn't veer off the road, then it gets a reward, for example. And in neuroscience, we might, for example, if we're doing experiments in rodents or monkeys, then they would be in a state where we know they might be hungry or thirsty, so that then giving them a food or drink reward is rewarding to them, which it otherwise wouldn't be if they weren't hungry, for example. So we're deliberately putting people or animals in that position where that we're fairly certain that that's what they're interested in. But we don't really consider that, well, that's also a kind of decision that our system has to make by itself. Like it sort of needs a separate layer to the whole learning problem, where you're using that reward signal to teach yourself how to behave better. But you're also sort of, in the first place, you need to decide, what is it actually that I want? And that's probably easy for things like hunger and thirst. Like, our bodies tell us fairly explicitly that that's what we should be doing. But it becomes a very difficult problem if, like, for things like, what career do I want to pursue, or things like that. And we just want to highlight that even in sort of fairly basic problems where you might be pursuing two goals rather than just one goal, there's already a lot of interesting data that we might want to look at, that where people might deviate from sort of classical assumptions. And again, we're sort of then at different bits of economics that have looked at that, of course, over in a sort of aggregate. But we just, like with this paper, we sort of wanted to highlight that that's not being considered as much in psychology and neuroscience at the moment.
Yeah, I mean, this is something I'm really interested in because, I do social neuroscience, so these social aspects are so, people's motivations for behaving, let's say in a classic economic game, there's always all these different considerations that go into it. So that's kind of why I found, I think also why I read this paper is just because it kind of has this, I'm really interested in this. How do you behave if you're not just trying to make money from a gamble thing, where basically that's the only thing you're trying to optimize. But what do you do if you have, you're interacting with someone, let's say you know them or only a bit or something, you also want to make money, but all these kind of things that suddenly flow into that. Right. That's something I'm really interested in. And maybe can you then, so it seems to me kind of your tentative suggestion, or maybe a bit more than tentative suggestion, is to use this thing called homeostatically regulated reinforcement learning, or that is a theory that has tried to address this or something.
Yeah.
I haven't been familiar with this outside of what I've read from your paper, although I'll certainly read papers from that soon. But what does that add to reinforcement learning, and how specific is it to homeostatic processes? So
the specific bits that we talk about in the paper are taken from a paper by Mehdi Karamati and Boris Kutkin, who've sort of taken the decades-old literature on homeostasis and sort of tried to stick that into reinforcement learning. And so this is essentially just providing a way in which, if you, let's say, have a goal, which might be, I don't want to be hungry, I don't want to be thirsty, then you can easily use the system that they've described to generate rewards that then you can learn about as a reinforcement learning agent. And they've shown that in a lot of different scenarios. It accounts for empirical data from, I think they exclusively talk about rodents. So we're sort of saying that, well, maybe if you sort of take the essence of this as like, there are probably goal states in the world, like you want to finish your PhD, and that sort of decomposes into, I want to publish this paper and then work on that paper. And how do you then use that knowledge to motivate yourself and to teach yourself whether something was good or bad? So we're sort of saying that, well, it's essentially a comparative process. So you have like an understanding or like a sense of where you are and a sort of sense of your goal state, and you're trying to measure the distance between them in some arbitrary way. And then as long as you decrease the distance to that, you're rewarding yourself. And if you're moving away from it, you're not rewarding yourself, you're maybe punishing yourself. And so we're sort of using this framework that exists for sort of low-level decision-making and saying maybe we can take it also to more abstract sort of decisions.
And there's nothing inherently that makes, I guess you suggested it as a general kind of thing, not just something that works only for specific kind of decision processes, right?
Yeah, I think it's fairly general. So the way what we've presented in the paper, which is like strongly based on the Karamati and Kutkin work, sort of assumes that your set point or your goal is always fixed. That's obviously not the case for a lot of interesting problems. And sort of the goalposts are constantly evolving. And so that would, of course, require quite a bit of extra work to make that fit. But I think that's sort of what I liked about their framework when reading about it, and when we've already collected data that spoke to this, and that's also something we talk about in the paper. I just think that it's a really important process that we should think about. Like, what is the reward generating process, and what are some properties of that we might want to measure? And I think that's something that really there hasn't been all that much work on. And it's certainly an active area in like machine learning in some ways, where you might teach your system to learn from experience that maybe going through a doorway is a good idea or something if you want to explore an area. But I think we don't know a whole lot about these phenomena. And it really, to me, like something I wanted to highlight with the paper is really that is a process that we really should think about more. Especially if you want to talk about more human-like phenomena, like, you feel satisfied when you reach a goal, or you feel disappointed if it becomes unavailable. And then sort of like, asking yourself, where does that signal come from? How does it originate? And then that's maybe not quite easy to figure out.
Yeah, I mean, because I did have a slight... One thought I had whilst reading is just like, what does this actually add that isn't already in the homeostatically regulated reinforcement learning framework? Is it this kind of combination of saying, look, people are doing this thing in this context, but we should also do it in this context? Do you see kind of what I mean? Because at some point I thought, like, but they've already said what's in the homeostatic context. Like, I mean, for me, it was useful just to, obviously I invited you because it was an interesting paper, not because I thought it was pointless. And, but do you see kind of what I'm trying to get at?
Yeah, I do. So, I mean, sort of the way this paper started was as a kind of discussion of the work that I'd done during my PhD. So that's sort of like, we sort of wanted to have something that summarizes the findings from my PhD, and those are sort of heavily based on that there might be certain goals that people are trying to achieve. And so these are the studies that we talk about. And then later on, we sort of found that the framework that they have for homeostatic decision-making actually might fit this quite well. So it's right that the framework that we're describing here is essentially their sort of mathematical framework, but it's a very different type of problem that we're interested in that they don't consider at all in their paper.
Okay.
So it's like, again, sort of taking that which you rightly say existed, but combining it with the work that we've done that might speak to it in the different domain of human decision making.
Mm-hmm. So still a few kind of they're all kind of general but not super linked. So I'll just ask them probably as a list the next few minutes. One question I had was, so you have this. So you say, okay, the question is, where does the value come from? And then you say, okay, we have these goals and we're trying to minimize the distance to it. Isn't that in some, so now the problem is where do goals come from? And I think this is also a header you have in here, right? Or something like that. I mean, another kind of critical question I had was, to what extent is this not just substituting one mystery with another, or is that just what we do in science? I'm not sure.
I mean, sure, it's a different, it's a very difficult problem to think about. Where are these goals coming from? But I do think it's a separate but related problem, because you can then have a system that tries to come up with good goals, for example, exploring your environment in certain ways, and then you can ask, what is the reward signal that system is generating to teach an agent how to behave well? So you can then look at two different aspects, essentially, of the same problem and interrogate whether maybe those signals that are generated by your goal system are reflected in some lower level brain areas. And as a sort of second point, I do think that these map onto different brain areas. So I think that the reinforcement learning problems that we might study in animals, they're often primary reinforcers, so food or drink rewards. And it's quite likely that these are fairly hardwired systems that rely on brain systems that are fairly ancient. But then we also have this whole lump of brain in the front of our head that sort of is the most expanded compared to other primates and humans. And that's the sort of area where we find things like longer temporal contexts and reversals and control that's switching between different tasks that we might be doing. So I do think there's at least that's sort of what I think might be the case, is that thinking about things as sort of like higher level states or goals is more likely to explain activity in prefrontal areas, whereas something that's like fairly low level, like rewards, might be more able to explain things like the basal ganglia, for example, where you might have investigated that.
But so another question related to that isn't it seems to me that it's kind of circular though, right? In the sense like, okay, why do you have goals? Because they're rewarding. So like, why would you have a goal if it's not rewarding? So then, yeah.
Right. I think that's true if you just have one goal, but as long as you have competing goals, then you can ask yourself, do they compete as a sort of pre-reinforcing state, or do they compete at the state where you are reinforcing your actions? But I don't know. I mean, that's like, I guess like the sort of brain starts with like fairly simple mechanisms, evolutionarily speaking, and then it sort of adds new layers to it. And I think all we're really saying is that, yeah, there's a new layer to it in a way.
And these are the kind of problems that it might try to solve, or it might be involved in solving.
Yeah, so I guess like it's also a question of granularity, I guess, in the sense that if you take classical reinforcement learning, then rewards are defined as a sort of state by state kind of signal. So on every single step, you might get a reward signal or something like that. But you might want to have a sort of, on top of that, you might want to have different layers of abstraction that sort of decompose the problem into, I don't know, rooms or like sub-goals, like writing a paper or something like that. And we know that there certainly is something that the brain certainly does that in various domains. But I guess the specific point we're making is that it also, like, that is where you generate your rewards from. It's not at a lower level.
And I mean, so I'm assuming that this is something that's not that well studied. But one thing I'm curious about is that, okay, so you have a goal that consists of multiple dimensions. Let's say it's just two, right? As you do in your paper. So in the I think the paper, if I remember correctly, they're linear related, right? Both are equally weighted and that kind of stuff. Has much been done on what happens if you have multiple goals that have different importance to the person, and these kind of things?
Yeah, so if you just look at decision making, then there's quite a large literature in economics that would look at, they might call it indifference curves or rates of substitution, where you might have a good A and a good B, and you have different preferences according to those. So you might be willing to give up 5 units of A to get 1 more unit of B. So you sort of lie on these indifference curves where the whole bundle of things is still worth the same, but you might require that you get a large amount of one good for giving up a small amount of another. So there's definitely a good literature on that, and there's another sort of more psychological literature on if you have things that have different attributes. So I don't know, you're going on a holiday, you might think about the hotel, the city, and so on, and you might want to integrate that into a single decision. But for what we're interested in is sort of like where not all of these attributes will factor in the decision that you're making. So it might be that you have these discrete things that you collect that are only rewarding in one dimension but not the other. And so you're continuously changing the state that you're in, or the amount of resources that you have, which is a bit different from like the multi-attribute sort of view. But there's certainly literatures that will probably have good links to this.
Yeah, I really need to read much more about reinforcement learning. It's like one of those topics I keep kind of, I want to get into, but then I keep doing these other studies.
I mean, it's incredibly vast, so it's very easy to get overwhelmed.
That's the next thing, yeah. Actually, that's a very good link to what I want to talk about next. Not exactly being overwhelmed, but on a kind of general level about doing a PhD.
Mm-hmm.
One thing that I don't know how to solve, and it's obviously I'm assuming, maybe you have it, but I'm assuming there's no one fits all solution. If you have it, feel free to say it. But like one thing in terms of that I especially have is that it's just how both in sense of like, is it possible? And also in sense of like, what are the steps and practically how would you do this? How am I supposed to learn all this stuff? Because you have this, if you want to do anything interesting, you have to, not necessarily have to, but you combine different things that haven't been combined before,
Mm-hmm.
right? So in my case, it's, if you have social decision-making or neuroscience, I'm interested in the kind of game theoretic aspects. I'm, interested in the kind of cognitive and computational neuroscience things.
Yeah.
There's also this whole evolutionary biology stuff. There's, basically it seems like most disciplines do game theory in some way or another, or it relates to it. This is leaving out all the technical aspects. Learning how to program, learning how to do all the open science stuff, all of that kind of stuff. So I'm just curious, like, for example, how do you go about learning reinforcement learning? Maybe as one example, like, is it, other than reading your paper, of course.
I mean, you just have to remind yourself that whatever topic you're studying, you probably can't read everything anyway. So there's definitely like, free yourself of the illusion that you haven't read everything yet, because you haven't. It's impossible. And that's particularly the case for something like reinforcement learning. There's like probably more papers published in a day than I could read in a month. So you just have to like get yourself to a state where you feel confident that you can run your experiment. I think, you don't just stop reading and learning then, right? But there probably is a point where if it's very new to you, you might be a bit unsure about it, and you just have to, I guess, trust your supervisor that they get a sense of, is this going to be novel and well motivated for the community that you want to address this for?
That's almost the hardest part for me, though. Like, I don't know what community I want to address.
Yeah.
I just want to do my thing. That's the kind of...
Yeah, I mean, that's good. I mean, you'll find a place for it in the end if you do what you're interested in. And that's definitely the main thing, I think.
Yeah, and it is also more confined. I think, because, I mean, at some point we did think, like, is this what we're doing relevant, like, for economics or something, right? Because I've been reading a lot of economics papers over the last 2 years, but at some points you realize, like, no, they won't care. And I actually had someone who knows a bit about the field tell me this, like, they won't care about this. Like, this is trivial to them because they don't, they have different goals and aims and questions and that kind of thing. But I'm curious, actually, so on a practical level, like, how do you, let's say you want to learn something new. Let's say you say, okay, I don't know, you want to get better at probability theory or whatever, something that's not, it's related to what you're doing, but it's not something you're going to learn on the job per se.
Yeah.
But might have these kind of long-term benefits. I keep like going back and forth whether I should do it in a block and just like take a course and online or something and just do it in like, 2 weeks and do it once, or to kind of spread it out over like half a year or a year, because then, both have kind of advantages and disadvantages, but.
Yeah. So if it's something quite mathematical, I personally find that quite difficult to just learn on my own, or just from reading and doing my own exercises. So for that, I would definitely recommend doing courses if you can. And for me personally, it would make more sense to do that as a block, or like a maybe 1 or 2 month kind of thing. These things also take a long time to learn, so you will have to invest a good amount of time. But something that definitely hasn't worked for me was doing a little bit of it 2 hours a week, and then I do it for a couple of weeks, and then it sort of fades into the background, and then I don't get back to it. So if you're anything like that, to just do the block course. And that's also something that's really difficult to do once you're no longer sort of a student, because then now you can rely on all the resources at the university and maybe even officially enroll in some courses. And afterwards, it becomes a bit harder to do these sort of fairly mathematical kind of things, I think.
You could still attend them, right? Or I don't know, maybe it depends.
Yeah, it depends maybe. I mean, there's also enough online courses that you can do. But I guess what really helps with these, like doing the actual physical courses, is that you would then be able to go to tutorials and you have exercise sheets, and that's kind of necessary, I think, for something as practical as learning how to do certain mathematical things.
Yeah. Have you had to do lots of that? I'm just curious, because I guess like for example, your PNAS paper, there's some mathematics in there, but none of it is exactly world changing.
Yeah.
But I'm curious, like how much you need to know to do that kind of stuff. Is it, some basic algebra and then you're good to go almost, or? I guess it's also the question, like how much do you have to learn about something, right?
Yeah, I guess it depends a bit. Like, if you're interested in the human behavior of it, then you probably don't need to worry too much about it, because then you won't be someone who's like coming up with a new theory for which you probably have to do lots of proofs and so on. So I think for everyday work, like a good basic knowledge of calculus, algebra, probability theory will probably get you a long way. But then for every kind of project that I did have to read up about some specific things. So for example, for this one, I had to read more about various types of probability distributions. For example, the Gumbel distribution that I hadn't really encountered before either, but it turns out to be quite important to it. And but I don't think for psychological research you really need that background. It's certainly helpful if you have it, I guess. But
yeah, so was it for you then a kind of having a base knowledge of those 3 areas you mentioned, and then advancing as needed on the job, or?
Yeah, I mean, in some ways, I sometimes would have wished I had a better formal mathematical background, especially when you're, as I'm sure you're doing as well. If you're reading economics papers, they're quite mathematical and maybe not always written in a way that's very reader friendly.
Yeah.
So for those, I often wished I had a stronger background in either the maths behind it or the formal economics. But yeah, it's a good base knowledge gets you quite far, I think.
Yeah, I mean, one thing I find just really interesting is that, for example, we did this linear algebra course that we kind of organized for ourselves. Mm-hmm. So we had this like MIT OpenCourseWare stuff and used that, and then we did this once a week, and then we got about halfway through, and then people went on holiday and everything fell apart when we started again. So that's exactly the way you described it. And actually that worked fairly well, even though we didn't have anyone who kind of knew what they were doing, helping us or anything. But for example, what I found really interesting is, we just did this further than I needed to really for what I was doing. And then suddenly, then you realize a few months later, I was like, oh, this is how this thing works. Like, I can explain this thing now. I didn't even know that this was what it was, but now that, you know it, these things become so much easier. And then, so since I had that realization, I think like, maybe I should learn as much as I can about this. Yeah. But I guess there's again the practicalities, right?
Yeah, I mean, I would certainly recommend doing that, but it is very time intensive, so there's a trade-off.
seems like you don't have a one-fits-all
I'm afraid I don't.
God damn it. Okay. Maybe as a kind of moving towards the end, let's say people are interested in, let's say they've read the PNAS paper or your where does value come from paper, and say, okay, this sounds very cool. I want to get started with this kind of stuff. So what would you, what are some kind of resources people might use? I mean, there's obviously the references in your papers, but those aren't necessarily the best places to start.
Yeah.
So I don't know, for kind of reinforcement learning, or not exactly what we would call the optimal utility paper in terms of research area, judgment decision making, optimality kind of thing. But do you have any kind of suggestions where people might start and what to?
Yeah, so starting with the more economic-y optimal utility functions paper, I did find it kind of hard to find good tutorials or resources on that when I started with this. I mean, this was like at the beginning of my PhD, not necessarily for this paper. I'm not so a good resource as for sure the Kahneman and Tversky prospect theory paper. That's relatively straightforward. And to have this sort of described in words, like not necessarily the maths behind it, but to get a sense of why economists have come up with all of this. I really enjoyed reading a book by Richard Thaler, who received the Nobel Prize in economics a while ago, called Misbehaving, I think. So it's a collection of lots of different behavioral economics findings. And he's also kind of...
I mean, that's his biography, right? Autobiography.
Well, it's a scientific biography, maybe, but...
Yeah, exactly. It's not about his family life, yeah.
Yeah, so I really enjoyed reading that, and it did give me some valuable background knowledge about my research. But yeah, you probably won't get around reading some fairly tedious papers along the way, I guess. So that's like the maybe slightly more difficult area. But for reinforcement learning, because it's such a big thing at the moment, there are a lot of tutorials and online resources that some of which are really, really good. So the thing that I really enjoyed and where I sort of learned about the more machine learning side of it was David Silver's UCL reinforcement learning course. So that's fairly comprehensive.
The one's on YouTube, right?
That one's on YouTube, yeah.
Started that, never finished.
Yeah,
I enjoyed the first 2 lectures. Unfortunately, I never watched the rest.
Well, it is good if you have a reason to watch it. I think you sort of need the motivation to be able to use it fairly soon afterwards, I think. There's that.
Is the reinforcement learning book a good starting point? Or I've heard from some people that it gets basically what you're interested in as a psychologist and neuroscientist is like the first few chapters, and then it's just computer science stuff that we wouldn't care about. I haven't read it yet.
That's right. So the first few chapters are definitely the ones that you'd be interested in as a psychologist, and afterwards, depending on what your specific area of interest is, it will still be interesting probably, but it becomes more technical towards maybe after chapter 7 or 8. But it is well written, and I enjoyed it as well. And so Chris actually has a sort of manuscript that he uses to teach a course. I think it's called How to Build a Brain. So that's this is like aimed at undergraduates in their 3rd year, I think.
That sounds like my level.
And it's I haven't read all of it, but the bits that I read I quite enjoyed, and it's quite accessible. So that's maybe a good easy starting point for people. It's on the lab website somewhere.
Okay, good. Then I'll find it. Yeah, How to Build a Brain from Scratch.
Yeah, that's yeah.
That sounds like. Oh god, it's 14 megabytes. There's lots of pictures.
It's
it's actually like a book kind of, or it's 211 pages. There's pictures. Yeah.
Yeah.
Yeah. For a second, I was like, oh, that's a long thing. But yeah, that's cool. probably learn more than I'm willing to admit on that one. Although I guess that's...
Well, I certainly learned a lot from it too.
By the way, one thing that just I also realized is that the about like resources. One book that I've really enjoyed. I'm not even sure how much it's going to help you become a better scientist, but I really love reading it. Is the Kahneman Tversky kind of double biography or working relationship biography by Michael Lewis.
Mm-hmm.
I don't know whether you've read that.
I don't think so.
Yeah, that's a really... I mean, Michael Lewis is if you don't know him, he's a non-fiction writer who, he had like a few years where like all of his books were made into into films. The Big Short, Moneyball, The Blind Side, a lot of those. I'd really be surprised if the Kahneman Tversky book isn't made into film fairly soon, because it's just absolutely lovely.
Mm-hmm.
So that might be another one.
Yeah, that sounds great. Yeah.
Okay, cool. Then maybe as my kind of last question is, what's next for Keno Juechems? And maybe related to that, just something I realized or noticed something you said earlier about, your bachelor's was very clinical and you weren't really interested in that. On your kind of St. John's website thing, it does mention though you're interested in applying this to patients with mood disorder. Is that kind of the outlook for the next few years, or?
So that would be some aspect of what I'll be working on, probably for the rest of my fellowship in some ways.
How long is that?
So I have it fixed 1.5 years and probably a year extension afterwards. So still a good amount of time. But it's now, so if we really wanted to work with clinical populations, then it's already maybe a bit late to finish it in the time frame. But it's certainly something I'm interested in, to collaborate with people. I'm not seeing myself move into that like as a sort of full-time sort of commitment. I do get most enjoyment out of the basics of neuroscience and psychology. And so more practically, I still have a bit of time on this fellowship. And partly because of the pandemic, I've switched a bit more to some theory work with kind of machine learning methods that would generate kind of what I talked about earlier, that might give you a teaching signal that's like, oh, you might want to explore this doorway, or you might want to use the information you have from previous tasks to sort of come up with good guesses of what you might be doing in a certain kind of task. So I'm working on that fairly technical side of things at the moment, partly because I didn't have the chance to do more brain imaging, which I would have normally done, I guess. Yeah, and then we'll see what happens then. So
after that, it's just open. Geographically, you've been in Oxford now for a while. do you want to stay there? Or I don't know. I'm just curious in terms of, I haven't been in one place for longer than 18 months, basically, since I left school, I think. So I'm always fascinated by people who spend lots of time in one place. I really like Oxford as a place and also as a research environment. And there are a lot of people who work on similar problems, not necessarily directly in Oxford, but London is just around the corner. So it's a great place to be, but it's also obviously very difficult to stay after a while. I'm not like fixed on the idea that I'm going to stay here realistically as well. And then, I would favor somewhere in Europe, but I'm not necessarily fixed on it. Okay. I guess we'll see.